This comet that you know of. There's one that's kind of famous historically. Hasn't been around since 1976, I don't think. It won't be coming back till like 2050 or something like that. Famous comet.
Halley's Comet.
Halley's Comet. Yeah, Halley's Comet. All right. So that's certainly a famous one. But there's one buzzing around us right now, and in fact, it's about as close as it's going to come to us right now. In fact, it passed as close as it was going to be last night. It's Comet C2025 A6, so-called Comet Lemon. What's kind of cool about that is that if you actually had a good enough telescope and could see it, it's got a kind of a green glow to it. And there's a few comets like that have that. I think it's a result of some diatomic carbon dioxide, or carbon, I should say, oxidizing or fluorescing, I should say. But anyways, comets, like the Earth and all the other planets, orbit in an elliptical path. And in fact, this is an ellipse. Can anyone tell me why this is an ellipse? Well, what about the shape of that equation says, yeah, that's an ellipse? Well, for one thing, both squared terms are positive. All right, so that's one of the criteria. Now, if there was only one squared term, what would this necessarily be? What kind of a shape would it be?
Parabola.
It would be a parabola, right? So it's got two squared terms. Now, if these had different signs, and they're both squared terms, then what kind of conic section would it be if they had opposite signs? Yeah, hyperbola. Awesome, thank you. So they have both positive signs. If they had both the same coefficients, then it'd be a circle. But they don't. So it's going to be this stretched version of a circle, an ellipse. And actually, a circle is kind of a special case of an ellipse. So an ellipse is more general than a circle. So we're going to do a couple more problems here in section 10.5. This is one that I wanted to do because it's probably been a minute since you've seen something like this. If we want to put this into standard form, and by that I mean x minus h squared over a squared plus y minus k squared over b squared equals 1, that would be our standard form. It would have a center at h and k. I mean, that's great, but we need to kind of play around with this a little bit. Let me show you what we need to do to play around with this. I'm going to take and factor out the coefficient of 16 from both these terms. And I'm factoring out both of them because I want to put these inside a set of parentheses and complete the square on that part of it. So it's going to be 16 times x squared minus, well, let's see. If I factored out a 16 from this, what would that leave me? 2. So a 2x. Now be careful. Only factor out the coefficient. Don't factor out the 16 and x. You're not trying to factor out a GCF. Okay, looking good. Now I got to decide what number I put in here to complete the square. Do you remember that process of completing the square? You take half of the middle coefficient, which would be -1, and then you take that -1 and you square it, you get a +1. That +1 sneaks in right here, and that -1 is going to help us factor it. Now, if I put a 1 here, I got to put something on the other side. I can't just say, oh, well, yeah, I'm just going to put a 1 here, because it's an equation. I've got to treat both sides the same. So what should I put on the right-hand side? If you're thinking a +1, you have to think a little deeper, because putting a 1 here isn't just putting 1 on the left-hand side. You got to distribute that 16. So what's the net effect of putting a 1 here? What have I added to the left-hand side? 16. So I'm going to add 16 times 1 to the right-hand side. Now the nice thing about what we did here is that we've got a perfect square. This is going to be 16 times something squared plus 4y equals 64, like that.
Is that 48?
Yes, it's 48.
Okay.
So the big question then is, well, what goes in here? And I like the way I do this here because it kind of helps you out. Can anyone, first of all, tell me what term I'm going to square to get this here? What goes in that binomial? So again, how much? X minus 1. Good. So that minus 1 helps you out with the factorization, and the plus 1 here helps you out with what you need to complete the square. So looking good on both of those. Let's finish this problem. That should be a squared here. To get it in this nice standard form, I want to have 1 on the right-hand side. So I'll take everything here, plus 4y squared equals 64, and I'm going to divide everything by, I don't know, 64. That way I get a 1 on the right-hand side. Now let's kind of clean things up a little bit. On the right-hand side, I do indeed get a 1. On the left-hand side, 4 goes into 64 16 times, so it's going to give me y squared over 16. Over here, 16 goes into 64 4 times, so I'll get x minus 1 squared divided by 4. And that's looking pretty good. There's just one more thing that I guess I would do to kind of clean that up a little bit more, and that is I'd rewrite each of these as squares. So what do I mean by that? I mean x minus 1 over what? 2 squared plus y squared over 4 squared equals 1. Now the reason for writing it like that is because this is going to tell you how far you have to go to find your vertices in either direction. So let me make that look a little bit more like a y. Well, let's start off this part. Where's the center of this ellipse going to be? 1 and 0. You're looking for the value of x and y that make the squared terms equal to 0. So the center is going to be at 1 and 0. And let's see. Center at 1 comma 0. So let's add that to our graph. That's going to be right here. In the x direction, I'm going to move a distance of 2 to the right and 2 to the left to find my vertices. So 1, 2, that's going to be right here, and 1, 2, I may have another one there. In the y direction, I have to move a distance of 4, so that's going to be up 4 and down 4, so that's going to put points here and here, like that. And now you can play your college-educated game of connect the dots. Please try and connect them a little bit smoothly. I know the Lions won last night. That was great, but I don't want a football here. I want an ellipse. And I particularly don't want people just connecting the dots like straight like that. That's kind of bad. All right, so there's, roughly speaking, our ellipse. There's one last thing that we can find for our ellipse, and that'd be the foci. Do you remember what we have to do to find the foci? Yeah. C squared is going to equal a squared minus b squared. Or the other way around, b squared minus a squared. It's whichever one is positive. All right. In this case, it's just going to be 4 squared minus 2 squared. So c squared equals 4 squared minus 2 squared. So c squared equals 12. So c is going to be plus or minus the square root of 12. You can just think of it as being square root of 12. Doesn't matter. there's no need in my mind to show off and rewrite that as 2 square roots of 3. You can if you'd like. This is going to be about 3.4 if you take out your calculator. So 3.464 if you want to really be precise. But it's all right. This is close enough that we can figure out where our vertices are, or where our foci are. Now the foci are going to lie this distance away from the center along the major axis. So that's going to be the major axis in the y direction. I'm going to start out at my center, which is 1, 0. If I want to move up to here to find that point, what are its coordinates going to be? Yeah, 1 and square root of 12. And likewise, 1 and minus square root of 12. Beautiful. Looking good there. All right. How are we looking with that one? To the right, kind of a refresher. Saw this stuff in college algebra. Good to see it again. All right, let's do another one here. Kind of like the reverse engineering problems. We're going to stick with an ellipse. Ellipse has foci at plus and minus 2 and vertices at plus and minus 5. So let's kind of keep track of things this way. We have foci at plus and minus 2, so that's here and here. You've got vertices at plus and minus 5 on the x-axis, so that's here and here. This is going to be an ellipse, so that means it has the general shape overall of x minus h squared over a squared plus y minus k squared over b squared equals 1. Let's start picking off things that we know about this. Can anyone tell me h and k? 0, 0. Remember, h and k is your center. And then looking at these points, our center has to be 0, 0. There's your center. So for us, thank you, James. For us, it's going to be 0, 0. Okay. Is there anything else that I know based on this graph? One of the other parameters. Because right now it looks like this. So right now we've got x squared over a squared plus y squared over b squared equals 1. Is there anything else that I know based on this?
A equals 5.
Yeah, a couple. I think Kaiser, you saw that as well. A equals 5. Remember, this is the distance from your center to your vertex, and that's going to be that term that's underneath the a. So a equals 5. All right, that's good. So now we've got x squared over 5 squared plus y squared over b squared equals 1. We're pretty close there. There's only one last thing we need to figure out, and that's b squared. But we're running into a little bit of a roadblock here. What could I do to figure out b? Well, generally speaking, math problems don't give you information that you don't need. I don't know what it is about math problems. They just say, okay, this is all you need, and they give you that, and rarely anything more. So what's one thing we haven't used yet? The foci. What is that distance? 2. And does anyone know a letter that I've used for that distance? C. Keep in mind that c squared equals a squared minus b squared, or b squared minus a squared. But the good news is we know what a is. A equals 5. We figured that out. And in fact, we know that c equals 2. Now, how come I know that a has to be the bigger of these? That I want to subtract it as a squared minus b squared, not b squared minus a squared, because that would give me different answers. How come a has to be the bigger of these? That's a good question.
Because it can't be negative.
Well, you're right. We don't want this to be negative. All right. Let's build on that a little bit. This would be negative if b was bigger than a, but I know that a is the bigger one because of what? Yeah, the major axis is along the x direction. This has to be the longer of these two, otherwise the foci would be someplace up and down. So a has to be bigger, so that's going to be c squared equals a squared minus b squared, or b squared equals 5 squared minus 2 squared, which would be 21. So b is going to be the square root of 21. Not so bad. Not so bad. Overall, your graph is going to look like this. X squared over 5 squared plus y squared over, you could do 21 equals 1, or you could put square root of 21 squared. Either one is fine with me. If you just want to leave it as over 21 and not have it squared, that's fine. I'm okay. WebAssign might be a little bit more picky than I am. Check that. WebAssign is more picky than I am, but yeah, some sympathetic nods there. But we're looking pretty good on that one. Okay, comments on that one? All right, so those are just a couple more that I wanted to do for you from section 10.5. And that's it.